Okay, ladies and gentlemen, welcome to the session. And today we're talking about percentage by mass of an element, molecular formula, empirical formula, and percentage yield. So how do you find percentage by mass? It's simple. You need first to find the relative atomic mass of an element in a compound, which is given by number of atoms times mass number, divided by the relative atomic mass of the entire compound. So look at this example. Calculate the percentage by mass of sodium in sodium carbonate. So how many sodium are here? It's 2 times the mass number 23, you get 46. Then what about the entire compound here? The entire compound here, you have 2 sodium. That's 2 times 23, 46. 1 times 12 is coming from carbon. 12, 3 times 16, 48 from oxygen. So the relative atomic mass is 106. So now we are going to come to sodium. Sodium we found 46 there, divided by 106 times 100%. So the percentage by mass is 43.3. So that's how we do it, as simple as that. Let's go to empirical formula. So now when we are talking about empirical formula, we are talking about what is the lowest ratio of an atom, of different atoms in a compound. So you look at each atom, how many atoms are there, each element in a compound. So the example that we have is find the empirical formula of a compound with composition 80% copper and 20% sulfur. So when you look at this question, the way you handle it, you have gone to write a ratio, and the way you write a ratio, based on what you've been given first. So copper is first and sulfur is second. So what is the percentage for copper? It's 8 divided by 64, the mass number. 20% divided by 32, the mass number. So you get this after dividing, then you get this after dividing. So between 1.24 and 0.625, which one is smaller? Is this one. So you divide everything by the smallest number. Now remember, there are situations where the number that you find, maybe it is written like 1.24, there is 5. You expect that you should round off. But for this one, even if this number is 5, you just get the numbers on top. You don't round off. Because the point where we just round off, it's just at the last point here. So after dividing here, then this is what was found. After dividing, this is what was found. So now here we can round off to a whole number. So it gives us 2. And this is what we get. Copper 2, then sulfur 1. So it's done there. Let's look at another example there. An hydrated salt has the following percentage. This is for iron, this is for sulfur, this is for oxygen, and this is for water. So we'll begin with iron, second sulfur, then oxygen, then water. Percentage there divided by mass number, percentage, mass number, percentage, mass number, or relative atomic mass. Then for water, relative atomic is 18. So after dividing, it was found 0.35, 0.35, 1.43, 2.51. So the smallest value here is 0.35, and everything will be divided by that. So here we found 1, here it was 4, here it was 7. So now how do you write them? Iron 1, sulfur 1, oxygen 4, then 7 belongs for water. Now we cannot write down 7 this side. We put a point and then write it in front because it belongs for the entire hydrogen and oxygen. So that is how it is done. We go to molecular formula. Now molecular formula here, we are talking about now the actual number of each kind of an atom in a compound. It's a little similar in a definition, but there it was the smallest. number, but here is the actual number. Now, how do we find molecular formula? So formula for molecular formula is empirical formula N. N represents relative molecular mass divided by relative empirical formula. So how do we handle questions here? Look at this question. The empirical formula of a compound we've been given. It's this one. Then its relative molecular mass is 88. Find the molecular formula. So first, you have to find the mixture for the empirical formula, which is 44. Then we are going to say relative molecular mass is equal to EFN. We are not at the molecular mass first. First, we deal with relative molecular mass because our idea is finding this. Okay? So now what we are going to do is, this question I've just picked it from there. If you notice there, that's where I've picked it. It's the same as this formula there. Relative molecular mass divided by empirical. So now what we do, EF appears at 44. That's the one we put here. Then 88 we were given in the question, relative molecular mass. Then both sides divided by 44, we get a 2. So we'll get back to the formula for molecular formula. So now where there's empirical formula, we'll write that formula, this one. It's the one I've written here. Then N we found 2. So now what you do is 2 times this, you get 4. 2 times this, you get 8. 2 times this, you get this one. So the molecular formula is done now. All right, so we look at the last thing, percentage yield. So now what you should bear in mind is when you're talking about percentage yield, we are talking about the ratio. It's the ratio of actual yield to theoretical yield multiplied by 100. So that's a formula for percentage yield. Actual yield divided by theoretical times 100. Now, what do we mean by saying yield? We mean how much of the product are you going to get after a reaction? So, after a reaction, there is actual mass that is going to be produced, and that's what is called the actual yield. But before, or maybe say after getting the actual mass, you can perform calculations using a balanced chemical equation to find out how much product we have produced. Okay? So now what you calculate on a balanced chemical equation is what we call theoretical yield. Remember that here we are now talking about products alone. When we are talking about limiting reagent, we are only talking about reactants, but here we are only dealing with products. So how do we handle questions? First of all, you should understand that what affects the actual yield are a lot of things. You find that what you calculate on a balanced chemical equation will always be bigger than what you actually get. And the reason is reactions do not go the way we plan them. Sometimes there can be impurities in the reactions that will affect the amount of product to be produced. Or maybe the reaction is reversible. Every time products are formed, products are turning back to reactants. Or maybe the vessel you are using has leakages. Some of the reactants are going out. So you affect the results. So let's look at this question that we have. This is benzene reacting with chlorine. It gives us chlorobenzene and the hydrogen chloride. So this is the mass of benzene that is reacting with chlorine. But the actual yield of chlorobenzene is this one. So now we want to find the percentage yield of chlorobenzene, this one. But remember, we've been given the actual yield. That is what is gotten after a reaction. So what are we going to do there? What we are going to do is, first, we need to write the mass ratio. And the mass ratio between benzene and chlorobenzene. Why? Because we are given the mass here of benzene. We are given the mass which is 36.8. Then we don't have the mass for chlorobenzene. So now we come here. The Mr. here, 78. Mr. here is this one. This was given in a question X. So this was the theoretical yield of chlorobenzene. So now you get to a formula. The formula is saying actual yield divided by theoretical yield times 100. Remember the actual yield we were given in a question, and this is the actual yield, 38.8 grams divided by theoretical, the one that we found from an equation, times 100. So we get 73%. That is the percentage yield. Thank you so much for watching. See you next time.